Alright, it's a preamble to what we're going to do today. We're going to learn how to express fx as a convergent power series. Remember, a power series is one where, can I have attention please, thank you. It's one where it is an infinite series, alright, with powers of x integer, positive integers. Okay? This may, for the next 1 hour or so, it may look, this may look very alien to all of us. In fact, when you're doing, you also don't know what you're doing. But never mind, trust me that you just follow the procedure. It's not a very difficult matter. It's just abstract, but it's not typical. Okay? It's just abstract, it's not typical. Just like when you do things like differentiation, sometimes it's abstract, but actually when you do it, it's not typical. Follow? So I give you a broad idea first. What we are going to learn is this. I give you an example. Example. We are going to try to express, say for example, e to the power of x. Now e to the power of x is very easy, right? You just key into a calculator. If x is 5, you just key e to the power of 5. Now, the next 1 hour, we're going to learn how do we express e to the power of x in another form, in a power series. That means convert, so-called convert, e to the power of x into a polynomial, a never-ending polynomial. Then you may ask, why would you really want to do that? Fair point, fair point. Why would you want to do that? I'll answer that later. But this whole chapter, this whole 1 hour, we're going to learn how to express ex in power series. Ex is just an example of fx. You can have a complicated thing like sine x cubed plus 2x. Also as a power series. Something like that. Can we do this in express it in power series? That means something x plus x squared plus x cubed plus x4 blah 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 blah. Follow so far? Now what is the formula? The formula is very simple. Okay, it doesn't look simple, but anyway, it's in MF26. This is the formula. And if you look carefully, what does the f prime and f double prime and f triple prime mean? Actually, it just means the derivative, the first derivative, the second derivative, the third derivative, and so on. And you are going to evaluate the values at x equals to 0. It doesn't mean a lot to all of us now. I'm going to give an example later on. Alright? But some of us may want to know, why? For the y, you refer to appendix B. I am not going to prove it here. Okay? If not all of us are interested, some of us are interested, you can refer to appendix B. Okay. Simple. Let's use example 15 to illustrate the point. I'm going to let's look here. This is from MF26. This one is MF26. I'm going to constantly refer to this to illustrate. Now, the first term here is f0. It's very simple. That means I substitute x. Can I have attention, please? I sub x equals to 0 in, I get ln 1, I get f0 equals to 0. So this first term is 0. So far so good. How do I get this f prime 0? I have got to differentiate this one time, which is not difficult. I get 1 over x. After that, I need to evaluate f prime at x equals to 0. I substitute 0 in, I get 1. Because 1 divided by 1, I get 1. Okay? Then I differentiate one more time, I get this. I substitute 0 in, I get negative 1. I differentiate one more time, I substitute 0, I get 2, and so on and so on. The question says that I need to stop until x cubed. I just need to stop at x cubed. I just apply this blindly. I say blindly in a very loose way. Okay, just refer the formula and just substitute. Differentiate, and substitute 0. That's it. Okay? Okay, this is easy looking at it. Later on, we're going to do some hands-on. Alright? Now the good news is that a lot of differentiation, a lot of these standard expressions has been done for you and is already given in MF26. All these are already done. Differentiated, substitute, differentiate, substitute. All standard series, all done for all of us. All okay. Okay? Alright? So whenever they ask for EX, you actually don't need to differentiate. This can be used without proof. It can be used without proof. All these, can I say can be used, include the first one also. Now, can I ask you a question? Do you find this first line familiar? You find this first line familiar? This is from what you learned earlier, the binomial expansion for non-positive integer. Now, I would like to explain why on your formula list, where is my formula list? I would like to explain why you see this line under Maclaurins expansion. Because actually this can be proven using Maclaurins expansion. You repeatedly differentiate this, you get f prime, f double prime, blah blah blah, in sub-zero in, you can actually prove this. This is actually a special Maclaurins expansion. Okay, this is a special Maclaurins expansion. Now, in fact, here, you refer to a tutorial question. This tutorial question would actually prove that result, would actually prove this result using Maclaurins expansion. That means using the fx. You all follow? Okay? Not very concrete, but never mind, we'll go through it one by one using examples. I want to emphasize this. For series expansion in sine cosine, x must be in radians. Now, in fact, I don't know whether you all have gone through tutorial 8. For all things, for all ideas in differentiation, integration, calculus, all your angles must be in radians. When you do differentiation, integration, it always must be in radians. So, Maclaurins expansion makes use of differentiation, therefore it must be in radians. Otherwise, the formula doesn't work. Got it? It must be radians. Of course, the more terms you have, the better is the approximation. Okay, never mind. Let's do this. Alright, example 16. Using the series expansion for ex and cosine x. Ex and cosine x. Now we must be quite familiar with this. What it means is this. You can actually lift off the series expansion for ex and cosine x from MF26. Can use without proof. Okay, can use without proof. But you want ex squared cosine 2x. Now what is ex squared? Ex is 1 plus x squared over 2 factorial. What about ex squared? You just replace x with x squared. Yes, replace x with x squared. So you get 1 plus this x squared, not x, because actually you have a ex squared plus x squared over 2 factorial plus dot. Now the question says that you need to have the first 3 terms in the Maclaurins expansion. So you must know when to stop. Correct? Question asks for first 3 terms. Correct? So you stop here. So you stop 1, 2, 3, done. Finish. Got it? Yes? Cosine 2x. Now, you want EX squared cosine 2x, right? So you want cosine 2x. But you are given from MF26 is cosine x. Come and see me later. You get 1 minus. Now this is x, so you replace x with 2x. So you get 2x square. Whoa. What just happened? Virus. Plus 2x 4 over 4 factorial. Okay, you just replace the x with 2x because you know what is cosine x. This can be used without proof, you just go with cosine 2x. Now you want to determine the first 3 terms of the Maclaurins expansion for this, so you multiply these two up like that. Multiply, multiply, simplify, and then we are done. Okay, I'm not going to go through, right? It's quite simple. Okay, pause the video.